Hello primary 6 students. The first unit in our curriculum this year is talking about force and motion. And today we will study the first lesson, which is mass and weight. Of course we studied mass before in primary 4, and today we will see the difference between mass and weight. In common usage, the mass of an object is often referred to its weight, but in fact they are completely different. They are different concepts and different quantities. First, we will talk about mass, or we will discover the concept of mass. We can say that mass is the amount of matter in an object. It means if we are talking about wooden chair, the mass of this chair is the amount of wood in this chair. So mass is the amount of matter that the object contains. And also we will study the properties of mass. The first property of mass is that mass of an object increase as the amount of matter increase. It means that the mass of 10 apples is more than the mass of 9 apples because the amount of matter, which is apple, increase. So mass increase as the amount of matter increase. The second property, all matter have mass whatever their physical state. If this matter is in solid state, it has mass. If this matter is in liquid state, it has mass. And also if it is in gaseous state, it has mass. So all matter has mass whatever their physical state. All matter have mass whatever their shape. For example, if we are talking about sugar, if it is one piece, if it is a sugar cube, it has mass. If it is particles, it has mass. And also if it is powder, it has mass. All matter have mass whatever their shape. And the most important point in this property is that mass is a fixed value and it doesn't change by changing the place. It means by measuring the mass of an object on Earth's surface and then measure it on Moon's surface, the mass will be equal. The mass of a book on Earth's surface equal the mass of the same book on the Moon's surface. So mass is a fixed value. It doesn't change by changing the state of matter and the place of matter. Then we will move to the measuring units of mass. The measuring units of mass are gram, kilogram, and ton. Gram is suitable for measuring small masses, such as jewelry, and it is equal the mass of one paper clip. Kilogram is suitable for measuring large masses as fruits and vegetables, and it's equal the mass of the 1 liter of distilled water. So it is suitable for measuring large masses and it's equal the mass of 1 liter of distilled water. And finally ton, it is used to measure very big masses. So measuring units of mass, gram, kilogram, and ton. What are the measuring devices of masses? We can say that mass is measured by different types of scales that can be classified into 1-arm scale and 2-arm scale. So measuring scales of mass are classified into 1-arm scale and 2-arm scale. 1-arm scale is divided into 1-arm scale, 1-arm digital scale, and 1-arm scale with pointer. 1-arm scale is divided into one arm digital scale and one arm scale with pointer. Two arm scales are divided into sensitive scale, which is used to measure small masses as gold and chemicals, and balance scale, which is used for measuring large masses such as fruits and vegetables. So the measuring devices of mass are one arm scale that is divided into one arm digital scale and one arm scale with pointer. Two arm scale, which is divided into sensitive scale and balance scale. After this, we will talk about weight. If we are talking about weight, we can say that weight is the amount of gravity, or weight is the gravitational force that attract object towards the center of Earth. To understand this part, try to answer these questions with me. If you carry your pen and leave it, what will happen? If you jump upward or jump up, what will happen? In both cases, if you jump, you will fall down. And also if you leave your pen, it will fall down. This is due to a force. This force is known as weight or gravitational force. So we can say that weight is the gravitational force by which the body is attracted to the earth. Weight is the force which attracts the body to the earth's surface. And we can say that the effect of weight is always directed towards the center of the earth. So weight is the force that attracts object to the center of earth. But this change in space, because we can say that in space all objects are in a state of weightlessness. All object is in a state of weightlessness. If you jump in space, you will fly, you won't fall down. So weight is the gravitational force by which the body is attracted to the earth. What are the measuring units of weight? The measuring unit of weight is Newton, and this is related to the scientist Isaac Newton, who discovered gravity. So measuring unit of weight is Newton, and the Newton is the measuring unit of weight, and it's almost equal to the weight of an object whose mass is 100 grams. Newton is the weight of it's almost equal to the weight of an object on Earth whose mass is 100 grams. So if we have an apple which its mass is 200 grams, can you measure its weight? Yes. Its mass is 200 grams, so its weight is 2 Newton, because Newton equal the weight of an object whose mass is 100 grams. Then we can talk about the measuring device of weight. Weight is measured by a device known as spring scale. Spring scale is a device used to measure weight. So we talked about the definition of weight, the measuring unit of weight, and the measuring device of weight. Let us move to the next part, which is factors affecting weight. If you remember with me, when we were talking about mass, we said that mass is a fixed value that doesn't change by changing the place. or the state of object. If we are moving to talk about weight, there are many factors that affect weight. The first factor is the object mass. By increasing the mass of object, weight will increase. So weight increases by increasing the object mass. And we can calculate weight by saying that weight equal mass times 10. Weight equal mass times 10. The second factor that affect weight is the planet where the object exists. We can say that as the mass of the planet increase, the gravitational force increase, so weight will increase. So weight is affected by the place of object. Weight is affected by the place of object. And we can say that the weight of an object on moon's surface equal 1/6 its weight on Earth's surface, because the mass of moon is smaller than the mass of Earth. So, on measuring the weight of an object on Earth, then measure it on moon, the weight will change. The weight of an object on moon's surface equal 1/6 its weight on Earth's surface, because Earth has greater mass and gravitational force than moon. We can say that weight change by changing the place. Weight is not a fixed value. Weight change by changing the place. The first factor that affect weight is the mass of object. The second factor is the planet where the object exists. As the mass of the planet increase, gravitational force increase, so weight will increase. We can give reason question here. Give reason. The weight of an object on moon is smaller than its weight on Earth. Who can answer this question? The answer is because the mass of Earth is greater than the mass of moon. And as the mass of the planet increase, the gravitational force increase, so weight will increase. The third factor that affect weight is the distance between the object and the center of the planet. As we said before, that weight always attract object towards the center of Earth. And we can say that as distance increase, weight will decrease. The weight of any body decrease when the distance between the body and the center of the planet increase. The weight decrease as the distance increase. So we can say that the weight of the person in a balloon is smaller than its weight on the Earth's surface. The weight of a person in a balloon is smaller than that on the Earth's surface, because as the distance between the object and the center of Earth increase, weight will decrease. This lesson finished, and I hope you studied, and I will see you later in the next lesson. Thank you.